Hey, this video is on derivatives, and what I'm going to do is I'm just going to give you a bunch of different functions, and I'm going to give you how to take the derivative of these things. So the idea is just to give you a wide variety of different types of functions that you might see. So the first one we're going to look at is the function f of x given by 3x divided by the square root of x squared plus 4. And so just like every time we've talked about things that involve square roots, what we can do and what we want to do is we want to rewrite them with a power, right? So we can rewrite this as 3x divided by x squared plus 4 all to the power of 1/2, because remember the square root is the 1/2 power. But now we're in a fairly good situation because we just noticed that this is just some function divided by another function. And when we want to take the derivative of a function divided by another function, we use the quotient rule. So that's the thing that we're going to use. So the derivative, so f prime, is given by the quotient rule. So we say, so it's low d high minus high d low over the square of what's below. All right, so here's the low times the derivative of the high thing minus high thing times the derivative of the low thing, x squared plus 4 square root, all divided by the bottom squared. So this is x squared plus 4 power of 1/2 squared. Okay, so that's the derivative. So well, we have to finish it obviously, but that's the general form of what it's going to look like. So we'll just keep writing. So we've got x squared plus 4 to the power of 1/2. The derivative of 3x is just 3. Then we've got minus 3x, and then the derivative of x squared plus 4 to the 1/2, we have to use the chain rule or the general power rule. So this is the 1/2 comes down, the inside of the brackets stay the same, and we subtract 1 from the power, right? So 1/2 minus 1 is minus 1/2. Then we multiply by the derivative of the inside of the brackets. So we're going to take the derivative of x squared plus 4, right? And then at the bottom, the one thing I want you to notice here is that we've got a power of 1/2 and then square. So really what this is saying is take the square of the square root. So, and remember also that when we have a power to a power, we can multiply them together. So 1/2 times 2, or the square root squared, it just gets rid of one another, right? So it just becomes a power of 1. So this becomes x squared plus 4 to the power of 2 over 2, right? Which is just 1. So this is equal to 1. So that's just a kind of a nice denominator to have. Okay, so let's keep going with this. So we can rewrite this as 3 times x squared plus 4 to the 1/2 minus, let's see here, 3x, and then you've got a 1/2 here, x squared plus 4 to the negative 1/2 times, then the derivative is 2x, all divided by just x squared plus 4, because the powers are gone, and that's good. Okay, so let's see. So what else can we do? Oh, right. So there's a thing here where notice that we've got a 1/2 here, and we have a 2 here, right? And everything's being multiplied together. So we can rewrite this again as 3 times x squared plus 4 to the power of 1/2 minus 3x times, now what I'm going to do is I'm going to bring the 2x over here, and then we've got the 1/2 x squared plus 4 to the minus 1/2, just so we can see this a little bit better, all divided by x squared plus 4. Now, we've got 2 times 1/2, so this 2 is going to cancel with that 2, and they're just going to go away, right? So what we're left with is 3 times x squared plus 4 to the 1/2 minus 3x squared. Now the reason why there's square there is because see how there's an x here and an x here, and we're multiplying them together, right? So that becomes an x squared, and then the 2's went away, and we've got x squared plus 4 to the power of negative 1/2 left, all divided by x squared plus 4. Okay, so let's rewrite this just a little bit. Let's get the 1/2 powers out and just rewrite them as square roots. Right, so 3 now is being multiplied by, so this is the square root of x squared plus 4 minus, now we've got 3x squared, but since here, notice that there's a minus 1/2 in the powers. So remember, the 1/2 power means that it's a square root, but the negative means it's in the denominator. So we can rewrite this as 3x divided by the square root of x squared plus 4, right? And then the bottom just stays the same. This is all over the fraction, so all over the denominator, x squared plus 4. And that's that. That's the derivative for that one. Next, we're going to look at the function g given by x squared plus 1 all times the ln of x squared plus 1 divided by 10. So yeah, the function looks a little complicated, but it's really not that bad. So there's a couple different ways you could approach this, but it's going to end up being almost identical either way. The one thing that we could do that I'm not going to do, but just so you know you can do it, if you wanted to, you could distribute, you could distribute the ln function into both, right? So you could multiply it out and then take the derivative of the individual pieces. But what we're going to do is we're just going to use the product rule because it's actually going to be easier, I think. So yeah, we have two functions being multiplied by each other. We've got this x squared plus 1 and this ln of x squared plus 1 over 10. So whenever you have two functions that are being multiplied by each other, the thing that you want to use is the product rule if you're going to take the derivative. All right, so what does the product rule say? So the product rule says take first times the derivative of the second plus second times the derivative of the first, right? So we're going to have first times the derivative of the second plus second times the derivative of the first. Right, so we've got that so far. So let's just take these derivatives. So for the first one, we're going to have x squared plus 1. And then we also know that the derivative of ln with a function on the inside, right, is just equal to the derivative of the inside divided by just the inside function. Right? So the derivative of the inside divided by just the inside. Then we have just ln of x squared plus 1 over 10 left over. And then the derivative of x squared plus 1 is just 2x. It's just a nice polynomial. Okay, so let's see, what else do we have left to do? So we have to take the derivative of the top here. So we've got the x squared plus 1. And then the derivative of the numerator here is just 2x divided by 10. And then we still have the x squared plus 1 over 10 left. Then we can simplify this side just a little bit, or not even simplify, just rewrite it as 2x times the ln of x squared plus 1 over 10. Okay, so how do we simplify this fraction over a fraction? So we can flip and multiply, right? So this is x squared plus 1 all times 2x over 10 times 10 over x squared plus 1 plus 2x times the ln of x squared plus 1 over 10. Okay, so the 10s cancel out, right? Because we've got essentially 10 divided by 10 here. And then this is equal to x squared plus 1 times 2x over x squared plus 1. And then we've got plus 2x times the ln of x squared plus 1 divided by 10. And then the neat thing here, what's happening, is that you've got an x squared plus 1 here and an x squared plus 1 in the denominator. Since everything's being multiplied by each other, you can cancel those out. And then you're left with just the 2x from the top. And then you got a plus 2x times the ln of x squared plus 1 divided by 10. And then we can factor out a 2x from both terms, right? So we've got a 2x, and this is being multiplied by 1 plus the ln of x squared plus 1 over 10, right? So, and just to see that that's correct, just multiply through by the 2x, and to see that you get this bit here. So just to make it a little bit more clear, the step from here to here is factor out 2x from each term. Okay, so that's the derivative of that one. That one's not too bad. It's just a matter of getting through all the fraction stuff. But anyway, so that's the derivative of that one. Now we're going to take a look at the function h of t, which is equal to ln of t times e to the power of t cubed minus 2. Again, this is something where we've just got two functions being multiplied by one another. So the first thing that we're going to want to do is do the product rule, right? So the product rule tells us, so h prime, it's first times the derivative of the second plus second times the derivative of the first. Oops, sorry. Actually, this is a good way to introduce this here. I just wanted to point out, I put d by dx, but the variable that we're taking the derivative of, or the derivative that, the thing that we're differentiating with respect to is t, not x. So if you notice before, I had a bunch of d by dx's here. Since the variable that we're working with here is t and not x, we have to say d by dt instead of d by dx because there's no x there to take the derivative with respect to, right? So you just have to be careful about that. And obviously I was not. So yeah, so d by dt here because this is the variable. Okay, but anyways, so we've got first times the derivative of the second plus second times the derivative of the first. And let's see here, what can we do? Well, the first thing that we know is that this one is the easiest derivative to do. The derivative of ln is just 1 over t. Okay, so so we can rewrite this thing fairly easily as the ln of t times, now I'll take the derivative of this later, so we'll say d by dt of e to the t cubed minus 2 plus e to the t cubed minus 2 times, and then the derivative of ln is 1 over t. Okay, so now the next bit, so we have this ln of t left, times, and then remember the derivative of e to a function is just e to the same function, but then you multiply by the derivative of the function that's at the top there. So we're multiplying by, oh, I did it again. Sorry, you want d by dt, not x. d by dt of t cubed minus 2. All right, and then we've got this plus e to the t cubed minus 2 divided by t. Okay, so the very last thing, we just take the derivative of that polynomial. So it's ln of t times e to the t cubed minus 2 times 3t squared. Okay, so that's that. That's all being multiplied together right there. Then we have this added e to the t cubed minus 2 divided by t. Okay, so how can we simplify this? Let's first, just to see this a little bit better, let's put the 3t cubed out, or 3t squared, sorry, out in front. Ln of t, and then we have e to the t cubed minus 2, and then we've got plus e to the t cubed minus 2 over t. So both of these terms have a common factor of e to the power of t cubed minus 2. So we are going to factor that out. So we've got e t cubed minus 2, and then that's all being multiplied by 3 t squared times the ln of t plus, and then there's a 1 over t there. And then again, just to see that that is correct, you can just distribute that e to the t cubed minus 2 back into each piece and see that you get the line above. But yeah, so that's the derivative of ln of t times e to the t cubed minus 2. Okay, here we're asking to find the second derivative of a function now. And the function here is 1 over the square root of x squared plus 1 all cubed. So just like before, whenever we see a square root, what we're going to want to do is we're just going to rewrite the function. So we can rewrite this as 1 over the, so we have x squared plus 1 cubed. And then remember, there's the 1/2 power there is the square root. So we have 1 over x squared plus 1 to the power of 3 over 2. And then we can put that in the numerator by throwing a negative sign in front of the 3 over 2. So now this is x squared plus 1 all to the power of negative 3 over 2. So now this is a little bit easier to work with. So that's what we'll be using to take the derivative. Okay, so now we got f prime. So we can use just the chain rule or the general power rule. So the negative 3 over 2 comes down. Then the inside of the bracket stays the same, and then you subtract 1 from the top. All right, so minus 3 over 2 minus 1 is minus 5 over 2. And then what you do is you multiply by the derivative of the inside. Right, so then the derivative of x squared plus 1. Okay, so if we do that, so we got negative 3 over 2, x squared plus 1 to the negative 5 over 2 times the derivative 2x. Okay, now same thing as before. There's a 2 floating around here and a 1/2 floating around. So just so we can kind of see what's happening, I'm going to bring the 2x over. So this is 2x times 1 over negative 3 over 2 times x squared plus 1 to the negative 5 over 2. And then it's a little bit easier to see that this 2 cancels with that 2 because, again, everything's being multiplied by each other. So you got 2 over 2, which is 1. And then now this simplifies to negative 3x times x squared plus 1 to the power of negative 5 over 2. Okay, so now what a lot of people would, they'd be happy and go, oh yeah, okay, I did it, I got the derivative. But you have to go back and you have to remember, the question is asking, find the second derivative of the function, right, that's given by that. So that's the first derivative. Now we have to find the second derivative. And remember, the second derivative is the derivative of the derivative. So really what we want to do, right, so f double prime, it's the derivative of the thing we just found. Right, so it's the derivative of negative 3x times x squared plus 1 to the negative 5 over 2. Okay, so now it's a little bit different, right, because we've got two functions being multiplied by one another. So you've got the negative 3x squared, and then you've got this x squared plus 1 to the minus 5 over 2. So there's two functions being multiplied by one another. Therefore, we should use the product rule, right? So what does the product rule say? Well, it says that it's first times the derivative of the second right, plus the second times the derivative of the first. Great, okay. So we've got that. So let's start taking some derivatives. So let's do, let's do this one here first. So we'll rewrite this as negative 3x times, we'll keep this the same for now, d by dx, x squared plus 1, negative 5 over 2. Then we've got this plus x squared plus 1 all to the power of negative 5 over 2 times, and then the derivative of negative 3x is just negative 3. Okay, and now we have to take the derivative of this thing, right? So we've got negative 3x, and then we can use the chain rule again, or the general power rule. So what happens is that you've got the minus 5 over 2 comes down, inside the bracket stays the same, and you subtract 1 from the top, right? So minus 5 over 2 minus 1 is minus 7 over 2, and then you multiply by the derivative of the inside. So the derivative of x squared plus 1, right? So that's all that. And then we just have this bit left over from the right-hand side here. So we've got just negative 3 x squared plus 1 to the power of negative 5 over 2 from this stuff right here. I just brought the negative 3 out front. Okay, so we have that. And let's simplify this a little bit more. So this is negative 3x all times 5 over 2 x squared plus 1 to the negative 7 over 2 times the derivative of that, which is just 2x, and then the minus 3 times x squared plus 1 to the minus 5 over 2 stays the same. And then I'm not going to bring everything over again, but I just want you to notice that everything from here to here is being multiplied, right? And then so the thing that to notice is that you've got a 2 in the denominator here and a 2 in the numerator here. So what we're going to do is we're going to say, well, these things just cancel out. So we've got a cancellation of those two. And so we can rewrite this as negative 3x times negative 5 x squared plus 1 to the negative 7 over 2. Then you got an x floating around still. So a couple things here. We're going to combine this negative 3 and this negative 5 together to make positive 15. And we're going to combine this x and this x together to give an x squared. But before we do that, we have to finish off what we have. So this is negative 3 all times x squared plus 1 to the negative 5 over 2. Okay, so after combining everything here, let's see. So the negative 3 times negative 5 is positive 15, and then the x times x gives you an x squared. And then you're left with an x squared plus 1 to the negative 7 over 2, and then you have a minus 3 x squared plus 1 to the power of 5 over 2 with the negative sign. Okay, so that's technically, so that's the derivative, but I'm just going to rewrite this so that we have some square roots back in there. So we can rewrite this as 15x squared divided by, let's see, x squared plus 1 to the 7, and then square root. And then we have minus 3 divided by x squared plus 1 to the power of 5, and then square root. Because remember, they're in the denominator because of the negative sign, and they are the square root because of the 1/2 in the power there. But anyway, so that's the derivative of that function, or sorry, the second derivative of the function 1 over the square root of x squared plus 1 cubed. Okay, so yeah, so this is not too bad. Again, it's just a matter of doing a bunch of practice. Try to do as many problems as you can. I've given you tons of practice problems to do from the textbook, all of which are odd numbered problems. So that means that they're in the solution manual. So if you're having some issues, take a look at the solution manual, and you can keep watching this video over and over again just to get the idea of what's happening. Okay, so here's the last problem that we're gonna look at. It's asking to differentiate the function f, which is given by the ln of x squared plus x times e to the negative 3x. So it looks like an ugly function, but it's not that bad. It's just that you have to remember the different rules that we have to apply. So first thing is that we've got some function shoved inside ln. And we know that the rule for this is if you have a function shoved inside the ln of, or shoved inside the long function, the derivative is just the derivative of the inside divided by the inside. So the derivative here is given by just the derivative of the inside, which is x squared plus x times e to the negative 3x. And then we divide that whole thing by just the inside. Right? So really the only thing we have to do is take the derivative of the top there. So let's see. So the derivative of x squared is just 2x. So we can rewrite this as just 2x plus, then we're going to take the derivative of x times e to the negative 3x. And then this is still all divided by x squared plus x e to the negative 3x. Okay, so let's see. So the only thing we have left to do is take the derivative of x times e to the negative 3x. So this is just two functions being multiplied by one another, right? So there's just an x and an e to the negative 3x. So we'll use the product rule. So what does the product rule say? So we got the 2x, and then the product rule says first times the derivative of the second plus second times the derivative of the first. And then this is all divided by x squared plus x e to the negative 3x. Okay, so let's see. Well, the derivative here, the derivative of x with respect to x is just 1. So that one's really easy. And then here, the derivative of e to the anything. So remember, it's just e to the whatever that's on top, and then you multiply that by the derivative of whatever's on the top. So let's do that. So this is equal to 2x plus x times, now the derivative here is just e to the negative 3x times the derivative of the top, the derivative of negative 3x. And then we've got a plus e to the negative 3x left over, because remember, this one here is just 1, right? So we're not worrying about that. So we're multiplying this by 1 here. Okay, and then we're all divided by x squared plus x times e to the negative 3x. So let's simplify this a little bit. So this is 2x plus x times e to the negative 3x, and then the derivative of negative 3x is just negative 3 plus e to the negative 3x here, all divided by x squared plus x times e to the negative 3x. And then let's see, what can we do to simplify? So I'll just bring the negative 3 over here. So let's just say, so this is 2x minus 3x e to the negative 3x plus e to the negative 3x divided by x squared plus x times e to the negative 3x. And that's it. That's the derivative of that one. Again, not too bad. It's just a matter of practicing and getting the hang of the rules that you need and when to apply them. Okay, so that does it for this derivative video.